Joshua had asked me to do is to give an overview of the one of the examples in the SDK itself, which gives a pretty good picture of how you would use the SDK in terms of getting it installed and getting started, but it is not a programming example of how you do every individual action that can be done. So if you guys have different questions or questions along the way, absolutely, just shout them out. But I'll just start and you guys can steer me as you need. So our SDK itself is cross-platform source code. You do get all of the source code, which means you can compile it with whatever compiler, the toolchain you actually use yourselves. I know that you received in the meeting link, you received a rather nice little synopsis. So I don't want to repeat a lot of that, but I'll show you places where that stuff actually applies. So what you see on my screen here is just a VM. All I've done on it is installed Visual Studio. In this case, I've installed Visual Studio 2015, and I have taken our executable, which is our distribution of the SDK. It's an executable on Windows, and I've just run it, and basically it's just an archive that gets expanded, and I've expanded it under the Visual Studio's normal location there where it wants to have projects, so under the Visual Studio projects directory. We have different distributions for different groups, so you'll get one that's named for you because the obfuscation that is done on the source code is it's purchaser specific. So this one actually says Honeywell because this one is designed for us internal use in Honeywell. So what we get is you get an executable, an exe on Windows, you get an archive on Linux, and it itself is just a collection of directories. And so when I open this up, you'll see that it's a collection of directories, and the most important ones in here are obviously the source code, and there's documentation. Now this happens to be, if you look at the name, it's R300.1. The naming schemes that we use is the 3 is the major version, minor version, patch version, and then revision is the 0.1. We're actually at revision 3. We've actually upgraded, but I've just used the first one because the 300s in essence are all equivalent in terms of giving an overview. Now, when you have this directory and you see the 3 underneath it, the main thing to note is that when you look in source, you'll see there's interfaces and internals. Internals is the source that has all of the obfuscated code. So you'll see that it's just one directory full of all sorts of funny names. The contents of these files are source code, but they're not human readable source code. The compiler sees them just fine. Linker will use them just great, but you can't use them. This is our internal IP for the SDK. So this isn't stuff that it's intended for you to have to be interfacing directly with, but it's the guts of how the operations run. This other directory under the source, this one called interfaces, is the APIs that you guys would be programming against, or the developers would be programming against. And in here, you'll see 3 directories. Client, which is no content at the moment because this version does not have a client in it. This R300.1 doesn't have a client. Common and server. And under these, if I expand them, you'll see that there's 2 directories under each. Platform specific and portable. Now, you guys have been told, I believe, that this is ANSI C++ 98 compliant. So that's all we need for a compiler. And what's under portable is completely specific to that ANSI compliance. So under portable, you'll see that there's lots of various code and directories. We've tried to name them so that they're completely logical for what's happening underneath. But this is all the stuff that is that'll run and compile for any platform and anywhere, and it's all type safe with the C99 types, and it's all available to you to see. They're all in C++ and header files, so this is all C++ code. Now under platform specific, what you'll see under here is a variety of different things. You'll see from the directories that it's different types of operations that are in each directory, and there's not just types of operations, but there's also platforms potentially under these directories and variations of platforms under these directories. Now this is where sometimes you may start getting some choices as a user of the SDK what you'd like to use. So if I just expand one of them here, TCP, you'll see by the naming scheme, you'll see that there's Windows and Linux sockets. ST means single-threaded, Windows and Linux sockets multi-threaded. So these are examples and reference code for you that are not part of the SDK directly, but are supplied by us so that you can either see them in the examples or you can actually use them in your projects. So if you wanted to write a Windows or Linux multi-threaded project, we have a TCPIP implementation of a stack for you already in this directory. If you wanted to do a single-threaded one, we have it there as well. And so, as you see in here, there is various pieces. Now this is reference version 1, so not everything has been implemented. We're now at 3, so we have much more implemented now. But this is what you'll see under platform specific. The other things you'll see under here, if I go into timers, I believe, you'll see that there's any platform and CPP 11. Now, the SDK itself is ANSI C++ 98 compliant. But if you have a compiler and a project that can use more advanced C++, where it makes sense, we've actually added reference code so that you could see it implemented in a more modern way. In this case, you can see a C++ 11, which would mean C++ 11, 14, 17, etc., depending on how it can be implemented in the newer C++. Or you can use the any platform, which is the 98, ANSI 98 compatible. So we do provide the compatibility and what we've said, but we also give you reference code for newer if you actually want to be able to use newer and you have a compiler and toolchain that can support it. So we've tried to give you guys every tool possible and reference possible to make it as easy as possible and as fast to develop as possible with as much variation so that your toolchain, the way you like it, can be used in your way and we can just fit in, as opposed to having to force you to modify your toolchain to work with us. And you'll see that there's quite a bit in here, and as we go forward and with new releases going forward, we'll just add more and more support for more things. So this is the general layout of the directory structure in the SDK as it comes. Now under it, you'll see there's common and server. Server happens to be specific for an OPC server. When the client comes out with our R400, client code will be under there. Common is the OPC types, those types of things that are all underneath here. The address space that's used behind the scenes, all of that. And there's a few other things in here that we'll get to, and we'll be showing specifically things, one in this miscellaneous directory. But not only is there the code for all of these things, there's also the helper functions that are available so that you can automate your development and make it much, much more faster in terms of having code that does a lot behind the scenes, but you only have to make one call, making a full abstraction of the UA available to you. If we look at here, I can expand this crypto. So crypto happens to be common. It's not server or client specific, so it's under common. We have a crypto directory here under platform specific. So with this crypto, there is also common code, and then we write 3 wrappers. Because we don't provide a crypto library for you. You have to provide a crypto library. But what we do is we write the wrappers that go to the 3 most common crypto libraries out there, so that if you choose one of those, you literally drop it in. And my example here that I'm going to show you actually literally drops it in and it works. But you can use any crypto library you'd like.
Right, okay.
So crypto is the one thing that you have to provide if you want security, and you should always have security. That's just a mantra that we want to talk to with everybody, is you should always be using security. So you have to provide a crypto library. And the crypto library itself, we use a certain subset of algorithms out of there. None of them are patented, so you don't have to worry about getting a patent license, like we're not doing elliptical curve or anything like that. we use the hashing functions and the actual encryption functions. We don't use the SSL or TLS type algorithms that are inside. We're using literally the low-level crypto and hashing out of it. Now, the three that we do have wrappers for are the embed TLS, which is, I believe it was originally called Polar and was bought by ARM, made into embed TLS, which is a freely available for everybody. Nano SSL, which is the premier paid crypto library from a company called Mocana. And then OpenSSL, which is kind of the de facto one on many platforms, especially on the Linux sides. So we have the wrappers that will automatically work with those. You just have to drop them in. But writing a wrapper is a little bit complex if you have your own library. But we have these three. You get them so you can see them as examples. And you do have the right and the ability to write any wrapper for any crypto library if you choose to use a different one. The other one that works in the same way, the other external library that works the same way or similar way is XML. We know people have very specific choices when they want to use a specific XML library. So we have XML wrappers as well. Here I show you TinyXML2. We also have libXML2 wrappers. And the example that I'm going to do has TinyXML2 right in it. So I don't have to actually include TinyXML2 because it not crypto. There's no issues about crossing borders and shipping the SDK. So we actually include that in this example right with it. But we also have the wrapper for libXML2 as well, which is one of the most common ones available. And the only difference between those two is TinyXML2 doesn't have schema validation. And if I just shorten this up, then there is a documentation. So we have SDK documentation. I did put on here in downloads the SDK R300 documentation. If you'd like to see the documentation later on, I can show you the documentation. So I did put the newer documentation on just for reference instead of the version 1 documentation. And then examples is the other one on here. And this is where you can actually see what the examples are. So we know that embedded projects often have C interfacing, or they're written in C, but our SDK is written in C++. So to help with that, we do have a C API that interfaces from a C project to a C++ or our C++ SDK. And that is an optional thing that you can use in the SDK. We prefer that you would probably use the C++ directory if possible, because we want to advance the C++ as we go to R400 or newer versions. We're advancing the C++ side, but we're not making more functionality available on the C API side. So the C API side itself only has the real-time communication functionality. It won't have the historical or the alarming functionalities that'll come in R400. But it is available if you have just real-time communication and a project that only interfaces in C. It's available, and you can see that we have two examples on there. Both happen to be Linux examples for the C API. For Linux, you can see we have Eclipse projects and we have Makefile projects, and we also have projects of different functionalities so that you can see something that, as a project that is closest to what you're trying to do. So single multi-threaded and with severe resource limitations embedded projects. And then on Visual Studio, we have with Embed TLS multi-threading. This is the project that I will be showing you as an example of. I happen to be on a PC, so it makes the best choice there. We also have the small micro and then no security single-threaded example for those people who may want a very simple sensor-style device that just doesn't have computing power to do any cryptography. And so we have all of these examples that are given, and they're all include as with reference codes so that you can actually include them right in your project. The examples that we make, we try to produce as if it was the quality of a production piece of software. We don't produce simple, barely functioning examples. So everything we do, you look at, you can say, yeah, that's what we want to do. The only caveat to that is when we have an example, we may have more than one way to do a specific thing in the example, and you may want to choose one style over another based on procedure or whatever works with your current style of programming. And that I will actually show you a little bit of as well. So if no one has any other questions on this, I'll actually start on exactly how you would actually start when you receive the archive of our SDK, how you would actually get your first sample project running. And to do that, as I said, if I was a customer and I had received the archive, all I did was, well, it was an executable and it expanded it into this directory. I haven't done anything to this directory other than it's just there. What I need to do though is I need a crypto library. Now I've mentioned this already that you need to supply your own crypto library. So the example I want to use uses embed TLS. Now I've already gone to their site and downloaded the free download of their crypto library, and I've expanded the archive and I've put it into here. Now the archive comes as a special archive, so I did that beforehand because it takes a while to expand. But I have it here, and this is literally how it comes, embed TLS, this version of it. Now with our example, if I go into the examples and I go into libraries, there's nothing in there. But if I take this and drop it right in, and there's documentation that says follow these steps, and this is exactly what it says to do. Drop this right into the libraries, and so that it's in here. I'm actually literally ready to go. Now, I didn't change any of the directories. I didn't change anything other than move that right in. And I can start Visual Studio, but I pre-started it because it takes a while to start up on a VM. Get rid of the start page, and now I can go File, Open, Project or Solution. And it already shows me where I'm going because I already told it where I was going to go. So the example I want is the embed TLS and multi-threading. And I choose my solution file. There's project files and solution files. So we already provide the actual projects, everything already set up for you. And this should open hopefully pretty quick here. And now we're up and ready. So what has happened is the project was created by our developers here. What we did is we just removed the embed TLS out of it so that it was easy to ship across borders for legal reasons. And all I've done is put it back in, so the project is now complete and ready to go. But there are a few things that we ask you as a user developer to do so that you have to note them and understand what they are. The first one that the documentation says is we have to go into the libraries. And you'll see it already has the embed TLS under here. We have to go into their include directories, and there's a file called config. And the reason we want you to do this, and the instructions tell you exactly where and what line to go to. It's 112 in this version of the SDK. There's this define embed platform memory. And the reason we get you to undefine this or uncomment this and define it is that when we're using the SDK itself controls its own memory. And we need the libraries that it uses. So not your application can do anything it wants with its own memory. But inside the SDK, we have to control the own memory. And since the crypto is loaded into our SDK, we need to make sure that we can use the crypto libraries using our memory handlers. And on Windows, we want to make sure that it's using the same heap. And so for a Windows build, we need to make sure that this is set, and that will force the crypto libraries to use the SDK's heap, and then we won't have any memory corruption. So that's the only change we need to do in there. And the only other change we need to do, and where I want to actually talk a little bit more, is in the SDK source files. So in here, you'll see that we have header files, libraries. Libraries was just the crypto library. We have the SDK source and source files. So the SDK source is all the internals and interfaces, as I've already shown you. Then we have source files, and we have this server example. This is the actual sample server that is used, that was written by us to run the SDK. But the file we want to change is in this interfaces. Remember, this is the public stuff. Common, portable, miscellaneous. And now the documentation does say where to go, so you don't have to remember all of these things. And we have this UA SDK Default Build config file. And this is a file that is going to have all of the major defaults of the settings for the SDK itself, for building the SDK. Now, this isn't necessarily all of the places for internal features, but this is where you would make the SDK build in the way that your toolchain wants it to build. So in here, we have many things. If you have this CAPI defined, then there's a whole bunch of defines that gets included. But some of the things that are in here are, and they get preset already, but are you doing Windows Linux multi-threaded, Windows Linux single-threaded, etc.? Are you using things like the Atomic CPP 11 implementation or the Windows implementation or the cross-platform implementation? So this is where all of these settings get set. And the only one I need for this example to change, I'll just give you some other major ones in here. As you see the UA SDK debug, we have the ability to have debug information on in the build, but not as a compiler debug option, but as a SDK debug option. That way you can actually debug release builds if you need to by using these options. And then we have subcategories of areas where you can actually focus on debugging so that you don't have debugging across the entire product where you know an issue may happen to be in one area. So we have some of that. But we need to come down here and say we're going to include security, because we're including security. And we have embed TLS on already, so this would have been ignored because the major security was off. So we're saying that we're going to be using security. So by having the user have to edit these two files, we needed to make sure that you had focused that these two things needed to be done, and these are places where options need to be changed based on your settings for your projects. And literally, for this example, that's all we needed to do. We can go, I won't do the debug version, I can do the release version. And I can actually just build the solution now. And as this builds, if you guys have any questions, this should only take a short time. So let's see how this is running. That's going through all of the obfuscated code, so you can't see what it is, but it's going. So let me give you some code bits and pieces as we wait for that to run. Now, when it's finished running, I'll run it, and all it puts up is a console window, so that you won't see anything special at that point. But what we have here in our reference example is we obviously, because this is the application itself, it's going to be able to do its own I/O. So this is a console application. We just use the standard C++ mechanism. We print right out to the screen. If you know about OPC and OPC UA, how an endpoint works, this is the endpoint. We actually put it up for you so that you have an easy access for a client to know where it goes to. Our default applications use 55,000 as the port, but in the code you can change that to whatever port you want. What we do in here is we set up a bunch of prerequisite configuration information for the SDK itself. So in here, this is obviously not the SDK. This is something trying to use it. The first thing we do is we set up a bunch of information about the SDK vendor information. So OPC UA servers always have vendor information. So we set up vendor information. By default, we just have Matrikon information set in here. What we do then is we set up some security information. This one has security policy basic 128 RSA 15. So in UA, there's security policies. Policies are groups of algorithms that go together in a certain way. This one line sets up an entire policy. There are 5 policies, and including there's also a none policy. We don't have that set up in here. Oh, actually we do, right above. None is outside of this if you're using in security. if you're using security, then which is one of that define we had to set, then we have add an extra one. What we also do in here is we set up the configuration options. So here we set up things like the port number we want to use. In UA, there are things that allow you to control how many client connections there are, how many items that they can subscribe to, how many or how much browsing information you can use up by memory resources, because you can use up memory and you don't want to have a denial of service attack. So we have limitations that gracefully limit how many clients and how much browsing they can do. So these are all limitations and settings that you can set. We've tried to set them to reasonable defaults, but you can actually set them to whatever your hardware or business requirements require you to. And then we have some things about debugging, setting up the listeners, and then we create server instances. Here's where we get into some very interesting stuff. OPC UA has an address space. So as a UA client connects to a UA server, it can browse it and see a hierarchy of what is in essence of folders and items. Now they're all called nodes in UA, but it doesn't really matter. We don't really want you to have to worry about programming all that in. So we have, via XML, we have ability to load an XML file in the SDK and actually parse that out and directly apply that to an address space. So this node set, this XML file is called a node set file. It's a defined file format by the OPC Foundation for defining OPC types and address spaces. For our instance here, for this we are actually loading an XML file that loads in the OPC types. So all of the various types, like the integers, numbers, all of the XML types, all of the bit streams, array types, all of those things are all loaded from the XML. In this case, you don't have to do this, but this is a very easy way to do it. And the XML parsers that we provide also are dynamic. So as the server is running, if your application wants to add new information, you can dynamically load in during runtime while clients are connected. You can load in new address space information and have it immediately applied to the address space. So that's part of our XML parser information. This is just information about where we're loading the XML file from. And then we go into more security information. So actually, first I'll tell you about this initialize call here. This is actually setting the server, basically setting the server up. We've set configuration is a structure which held the information from before about the security policies going to be used and the vendor information and the settings for port number, etc. That's all held in the structure configuration. That's what we set. And then there's something called the number of threads. So this is the threading model we're using. This computer I'm on right now is a dual core with hyperthreading, standard Windows laptop. I've chosen 10 threads. I could choose 4 or I could choose 50. Whatever makes sense for me. So you have the ability to do that. You could also query the system and dynamically determine the number of cores available and put that in here as well. So you have the ability to control the threading as well, including using a single threaded model. We're fully functional on a single threaded model. And so the next piece on here, the piece I was going to get to, is the crypto. So this is if you don't have a certificate for your instance of the UA server that you're creating, this will create a UA self-signed certificate for you at first start. Now, we don't suggest that you make an application or actual product with self-signed certificates. That's probably a bad choice. And the SDK, if you have a certificate available, the SDK will use the certificate that's applied. But this is for an example project. So normally you'd be running this, and you just be ad hoc running this. And if there's no PKI available or no certificate for the PKI, then we'll create one for you and you'll be able to use that. And it just sets the settings that are available in it. I won't worry about changing mine to my actual IP address. I'll just use the default for my certificate. I'll just get a warning if I use the certificate. It'll say IP address mismatch, but I can just accept that. So we do all of these things for you. And some of the other things that we do down here is we had loaded the type system, we could have loaded the address space via XML, but we can also do it programmatically. So we've got in here, I've create a folder through programmatic means. So I'm creating a folder called my folder, and then I'm creating folders called my stored value, or my stored value, my synchronous, and my asynchronous stored values. So when I'm creating folders like this and creating items like that underneath them, then I can do that programmatically as I need to, depending on how my project runs. If it's a very static embedded product like a sensor, I can statically create these via coding. I can also dynamically create them via coding if I have something like a PLC where someone changes a program in a PLC. I can have code that detects that and then creates the appropriate items in folder structure in my UA server right at execution time as well. But compile time, execution time, and XML loading, they're all ways that you can do your address space. And the address space is really the heart and soul of a UA server. What you really do is you have a client connect, browsing through, connecting into the address space, and then the address space itself is then connected to the registers in your application, asking your application what is the value of these registers, and then your application returning that back so that we can fulfill the OPC client's requests. And it sounds like it's not doing much, but UA has a lot in it, and we try to abstract all that away. And then down here is the actual run of the server, which is server, now go do what you need to do. And remember, a lot of the stuff that we've done above can happen after this run is actually called. It can be dynamic. So yeah, our server is a full server. R400 is a standard server profile compliant, which includes all of the predefined OPC types, all of the node types, so variable types, standard node types, all of them, and all of the defined reference types. You can even define your own node types and reference types and variable types. So right now I've got this built, and you guys can continue asking your questions. I'll just start this up since it's dead simple here. So I've got my examples.
Rod, are there any metrics you have on the memory consumption of creating one node so we can get a handle on the memory pressure of a large address space?
Unfortunately, I don't have that with me. I'm actually doing this from home. The temperature outside is minus 41 Celsius with the wind chill where I live, and I walk to work. So I've chosen to do this from home today. That information is at my office. But we do have some metrics. What we did is we created the R300.1, and then R300.2 was support for more types of kind of esoteric compilers and toolchains. And then R300.3 was an optimization on the address space and memory size. So we did some reductions of address space and just the code size of literally the code footprints for the really small embedded. So those metrics we did collect so that we knew where we started to and where we got to. So and if you're watching your screen, here's the SDK running. Dead simple. There's nothing really to show with the SDK running, and it has just a simple address space. It doesn't have much included in just a few items that were added. And this is, of course, a Windows 64-bit build, so it gets rather large being 64-bit Windows because our platform layer for Windows does include the C runtime, but that's our example code. The SDK code itself does not rely on the C runtime.